Hi, welcome back. In this lesson, we are going to use a case to understand one-way ANOVA. So this is the case we are going to deal with. There are four. There are three varieties of wheat. Okay, A, B, C, and these wheats are shown in four different types of plot. These are the plots of the land. Four different lands are there. So this is the production per acre. That what we are getting for different land, for varieties of seeds that we are getting the productions per quintal we are getting. Similarly, for A we are getting, for B we are getting, and for C varieties of seeds we are getting. As far as A is concerned, A variety is concerned, total production we are getting 24 quintals. And as far as B is concerned, we are getting 20 quintals, and C is concerned, it is 16 quintals we are getting, okay, from different lands. So N1, what N1 tells about? N1, these are all calculated. When we talk of T1 and N, T and N are calculated. Okay. N means values in the row. How many values are there? 1, 2, 3, 4. Okay, these are the four values. Therefore, here 4, here also 4, here also 4. We are getting 4, 4, 4. So this is the grand total. Grand total means total production that we have extracted from different varieties of seeds. Okay, from the plots. Okay, total. This is the N means total. That is N1 plus N2 plus N3 that we are getting. Okay, that means elements in the tables. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the four. These are the, if you see, these are the values that we have got. These are the total 12 values that we have got it. Okay. So first thing that we must remember that when we select a particular kind of test, the data that we have been given must fulfill certain assumptions. So assumptions for ANOVA, we must remember that the sample must be more than 2. Okay. This is A, this is B and C. That is more than 2 means we have 3 samples here. Total 3 varieties of wheat. That means first assumption is fulfilled. Second assumption, the data that we have been given, those must be numeric or metric data. So these are the numeric and metric data that we have got. Next assumption, very important, we must understand. So when we make plotting of all these data, they must form normal distributions. Okay, that means it should come in a bell curve. This is the basic assumption. Because it is a parametric test, we must see that the value must make a normal distributions. Okay, we assume that the data is normally distributed and data is also homogeneous. Okay, these are the assumptions. We assume that data is normal and homogeneous. Then we can use this parametric test that is called one-way ANOVA. This is called one-way ANOVA. What we are going to do here, the mean score of A, B and C, we assume that these are all same. Okay, as far as production is concerned, all means of production concerning varieties of seeds are equal. That we assume. That means there is no significant difference. Difference is obvious, but we assume that there is no significant difference. Means difference is insignificant. And H1, that is that is the alternative hypothesis, that we assume that at least one of the means is not equal or different. That we are assuming. The first step in ANOVA, that we have to calculate the correction factors. Okay. So correction factor is calculated by this formula, that is T square divided by N. What is the T square? T square is this is the T square that we have calculated, sum of all values. Okay, that is a 60 quintals we have got, and this is the N. Okay, number of samples, number of values in the cells that we are giving. Okay, in the both in all the cells. Okay, this is 4, 4, 4 we are getting. So this is 300 we have got. We have got this is 400. Next step in ANOVA, that is SSB, that means sum of square between, that we have to calculate. Okay, so there is a formula for this, T1 square by Tn. This is, you can see, this is T 1 square, 24 square divided by 4. Okay. Similarly, plus 20 square divided by 4. Similar plus 16 square divided by 4 minus 300. This is the correction factors. Okay. Equal to 308 minus 300. We are getting this value, that is called 8. We are getting. Next step in ANOVA is that we have to calculate, this is SST, means sum of square total. That means all the values that we are getting, like 6 square, this is 7 plus 7 square, then 3 square, then 4 square, plus 5 square, 3 square, 7 square, this is 5 square, this is 4 square, plus 3 square, then plus 4 square. So that minus correction factor, that is a sum of xij, means values in cells. Okay, elements in the tables or values that are given in the table. So we are making the sum of all these, and what we are doing, we are making the square and deducting from that, we are deducting correction factors. Just you can see we have done. So all the values that are there in the table, we are making the square and making the sum, and finally we are deducting correction factor, that is called 300. So we are getting 32. So this is the value that we are getting. So now we have got SSB, then SST we have got also correction factors. Then what we do? So we have to calculate SSW, means sum of square within. How it is being calculated? Equal to SST minus SSB. What is SST? SST we have found it, it is 32. Okay. Then minus 8. Then we are getting 24. We are getting, okay. Okay. So then we have to prepare this table. Okay. Sources of variations. We have got the variations. So first is that this is SSB. We have got. So what is SSB? SSB value is 8. You can see this is S8. So we have written here 8. Then we have got SSW. What is SSW? We have got it 24. So we are putting just here the values. SST we have got it 38. Okay, these are all calculated value. Then we have to calculate the degree of freedom. This is the degree of freedom. This is very important because we have to find out the table value for this. Okay, because we have to compare the calculated value with the table value. Okay. So then we have to, this is k minus 1. What is the k? That means number of samples. Number of samples A, B, C, 3 varieties of seeds that we are getting. Therefore, we are getting 3 minus 1 equal to 2. Okay. SSW means total. Okay. That is within. SS sum of square within. So n minus k. N, what is n? N is 12. We are getting here n 12 minus 3. Where is 3? Means 3 variety of seeds. Therefore, we are deducting this. This is called 9 we are getting. So here we are getting n minus 1. Because this is 12 minus 1 or 11 we are getting. Then next step, that what we are doing, mean square we are calculating. This is sum of square divided by degree of freedom. Sum of square we have got SSB, sum of square SSB 8 divided by 2. That means this cell divided by these cells we are going. Okay, 8 divided by 2 equal to 4. That is called mean square between. Okay. Then similarly for SSW we are getting 24 divided by 9. We are getting this value 2.67. So a value calculated, then we can also derive from. Once we get both, like the mean square between and mean square within, then what we can do, we can also calculate a value. Like this is MSB divided by MSW. MSB is 4 divided by 2.67. So equal to, we are getting 1.5. So then next step, now we have got the calculated F value. Calculated F value we have got it. Then we have to, what we have to do, we have to find out the table value. This is the table value. Table value what? Table value tell table value, it is telling f, you can see this is f degree of freedom 9. Okay, f2 and 9 degree of freedom 9. We can see this is degree of freedom 1. 2, where this 2 comes, because we have got it, this is A, B, C, 3 variety of seeds, therefore 3 minus 1, 2. Then another we are getting here, this is called 9 we are getting, because n minus k we have calculated here, that is called 9. So therefore we can see here, this is 2 degree of freedom we are getting here 2, and here it is 9 we are getting. Okay, so this is the value we are getting 4.26. We have written here 4.26 we have written here. Now this is the like tabulated value, this is the calculated value that we have got. So now we have to make a decision whether H0 is accepted or not accepted. So simple thumb rule, if F calculated is less than F tabulated, accept H0. So this is the F calculated 105 is less than the tabulated, this is called 4.26. Therefore we have to accept H0. What is H0? H0 is all means of productions concerning varieties of seeds or varieties of wheats are equal. That means there is no significant difference in mean of production as far as the wheats or varieties of wheats are concerned. This is how we can conclude. Okay. So these are the basic steps. First of all, we have to understand the data. Then we have to see that basic assumption of ANOVA data must fulfill. Then we can start with correction factor, then SSB, sum of square between, then sum of square total, then sum of square within. Then we can prepare the ANOVA table. Okay, we can that put all the values of sources of variance, then sum of square values, then degree of freedom. We can calculate also mean square. Okay, and F calculated. Then we can go for F tabulated. Then we can compare both F calculated and tabulated, and we can make a conclusions whether H0 is accepted or not accepted. That's for the lessons. Thank you.